Hi there, this is lecture 10, 9.3 on percents. And so I've kind of picked out a handful of problems that often give people difficulty, and I want to go through those specifically. So there are three types of them, and the first one are the questions that I categorize as fair or not. This usually means that they're asking you to look at two different scenarios and say, okay, are these equal? Are these one larger than the other? Something like that. They often don't give you all of the information. So usually you have to make something up. And I'll show you that in a second. Okay, so here we have number one. The boss says, you remember when business was bad last year, I had to cut everyone's pay by 10%. Well, business is better, so I can raise your pay by 10% now. That will put you back where you were before the cut. Is the boss correct? Okay, so we want to analyze this and say, can we justify that this is exactly the same and you will end up with the same amount of pay, or it's not? Okay, and the way that we do this is we're going to make up some kind of label, some kind of number here. So if I'm kind of looking at what's going on, right, first we have a pay cut. So let's analyze the pay cut first. So we're going to have percent across the top and dollars, because that's what you get paid in. And let's see, there's gonna be an old pay, right? Your original pay, and then they're gonna cut it by 10%, and then you're gonna have the new pay, or what I'm gonna call the lower pay, just so I can be specific. Okay. So your old pay, the cut, and the lower pay. We know that the cut is 10%. Okay. Anytime that you are doing an increase or a decrease, which we're going to talk about a little bit later, the old is always the 100%. So let me say that again. The old is always the 100%, whatever you're coming from. Okay. The other thing you can look at is it's always the thing that comes after the percent. So here's the percent sign, and the word now comes after that. So, or cut their pay by 10% of their current pay, right? And so the old pay is 100%. And if the lower pay, then you're just going to subtract. So you had 100%, they're cutting it by 10%. So now you have 90%. The problem is that this problem has no dollar amounts whatsoever in it. So in order for me to figure this out in a more concrete way, I'm going to pick a dollar amount. Okay. And you can make it whatever you want. You could pick 100 because it would be almost no effort in converting your ratios. I'm going to pick 20 just because, right? $20, say you're making $20 an hour. Again, you can choose whatever number makes the best sense for you. So then we need to figure out what these other numbers are. Now, I like 20 because I can kind of use a factor of change strategy here. So we could just divide everything by 5, because 100 divided by 5 gives me 20. So if I divide everything by 5, what happens is that 10 divided by 5 is 2, and 90 divided by 5 is going to be 18. So that your new pay, or your lower pay, is $18. Okay, now if you don't like that strategy, then back the train up here. And let's use a cross multiply. A lot of people like cross multiply. So I'm going to say, let's find the cut, the amount they're cutting your pay by, and then you can just subtract it. If you want to find the lower pay, you can, but I choose the cut because I can just draw in my fractions and my equal sign. Make sure that when you're using cross multiply, you do have 2 fraction bars and an equal sign. So then you can go ahead and cross multiply. That's going to give you 100x equals 200 when you cross multiply the diagonals together, right? Divide by 100 on both sides. It's going to give you x equals $2, right? And that's the pay cut. So you're losing $2, and so if you subtract it from 20, that gives you the $18, right? And that gets us our lower pay. So business was bad. They cut your pay from $20 to 18. Now they're going to say, okay, let's raise your pay 10%. See if you end up back at 20. So part 2, we're going to go down here and we're going to set up another set. So it's still percent and still dollars, but now we're going from your lower pay, and they're going to raise it, and you're going to have a new pay. And the question is your new pay the same as your old pay? So now the raise is 10%. And now your current pay, or the lower pay, is the old, right? You're going from the lower pay to the newer pay. So the lower pay is your 100%. And that means your new pay is, if you add that together, because now it's a raise, so it's positive, you're adding together, that's 110%. Question is, what's our money value? Well, we know that your lower pay was $18. Okay, so now what I'm going to do is I'm going to find this X to find the raise to see if you end up back at 20. So in order to get back at 20, our raise has to be $2, right? So if we cross multiply here, that's 100X equals 180. And if we divide both sides by 100, we get that X is equal to 1.8 or $1.80. So that means your new pay, when you add 180 to 18, means your new pay is $19.80. And is that the same as your old pay? Did that get you back to $20? No, it'll get you close, but it's not going to get you there all the way. And the reason for that is because that 10% is taking 10% of a different amount of money. So when it's taking the 10% in the cut, it's taking 10% of your old pay, which is a higher pay than your new one. So if you're taking 10% of your old and 10% of the lower pay, those are going to be different amounts of money. And so it's not going to get you back to the same thing. Okay. So the moral of the story, or the takeaway from this, is that you're taking the same percent of a smaller value for the raise. So pay attention in general to what you're taking the percentage of. Okay, that's the key thing when you're talking percents. What are you taking the percent of? And in this case, that 10% is of two different values. So the lower value is not 10% of a smaller number isn't going to be as much as 10% of a larger number. Okay. So you're going to see various problems that are similar to this, in which you have to choose how much something costs, how much you're making, or how much the shirt costs, or how much something is. Okay. The next one is multiple percents. And multiple percents refers to problems where you just have a lot of things going on. Okay. Usually you're going to have lots of things in your categories, not just one or two or three. And you might have to combine things or separate them depending on what's going on in a second chart. Okay. So it's going to look something like this. So D has a part-time job and wants to buy a car. She figures that she spends about half her income. So when I see the word half in terms of percentages, I'm thinking 50% income on her apartment rent and utilities, and about 12.5% on food, for a total of $450 per month. She wants to allow $10 per week for entertainment and incidentals. About how many dollars are left for car payments and car expenses? Okay, so we're talking in terms of our labels in percent, and you're talking about money, so dollars. And then we're going to read through this. So her apartment rent and utilities, these two things she's lumping together, and that's the half. So rent and utilities, and I'm going to move this over a little bit. Is going to be 50%, right? That's what they list. We've got over here, food is 12.5%. So food is 12.5%. She wants to allow $10 per week for entertainment and incidental. So I'm just going to go entertainment. And we can assume that there are 4 weeks in a month. We're not going to make this super complicated. So that's $10 per week. So 4 weeks in a month would be $40. And then what's left? Okay. Now, when they talk about the half or the 50%, what comes after that from here, percent of her income. So that is her monthly income, and that's not in my list. So I want to include that. So total income, because that's my 100%. Okay. Now, what we're looking for is how much money, how many dollars are left for car payments and car expenses. So you're trying to find this one, what's left in dollars. Okay. Now there's one other one that we didn't put in here, and that was the $450 a month. And the reason for that is because that $450 refers not to your rent and utilities or food, but both of them together, right? Apartment rent and utilities, and about 12.5% on food, for a total of $450 per month. So together, this has to be $450. Okay. So here's the thing. I don't know what dollar amount is each thing there. And what needs to happen here is I need to have what I call the bridge between the two, meaning I need a value that is both on the percent and the dollar sign, so I can use that to find some other value. Okay, so I don't have a bridge here because something weird's going on with this first thing. So what I want to do is I'm going to rewrite this chart, but I'm going to combine those top two categories together because their dollar amount is given together. So let's do that. So let's create a second chart where we put still percent in dollars, but we're going to go rent, utilities, and food all together. And that way I have 50% rent and utilities, 12.5% food. So altogether that's 62.5%. Okay. And together it's $450. And there's my bridge. Okay. Entertainment, we have under $40. What's left, we want to know what that X is. And then we have the total income. And that's your 100%. Okay. So now I have some options here. So I could figure out, so option one, I could figure out what percentage entertainment is, right? That would lead me to find out what percentage is left. And then I could convert that over here to dollars, okay? Or option two would be, okay, well, let me figure out this one. Let's figure out how much money you make in a month. And then I can just subtract the 450 and the 40 to get this box here. Okay. Either strategy, totally fine. I'm going to choose the one that uses less steps. So I'm going to go the yellow option. So what I'm going to do is I'm going to find, and I'm going to use the letter Y because it's not the X that I'm looking for. I'm going to find the total income in dollars. Okay. So that means when I go to do this, I'm going to go percent in dollars. And I need to include my bridge. So my bridge is this one up here. So I want to include that one. So rent, utilities, food, and that's 62.5% and $450. And then I'm going to include the one that I'm looking for. So that's the total income. And that's 100% and Y. Okay. And I'm going to go ahead and cross multiply. So I'm going to put in my dollar signs, my fraction bars, and my equal sign. Now I'm ready to go ahead and cross multiply. So that's going to give me 62.5Y is equal to 45 followed by 3 zeros, so 45,000. Then we're going to go ahead and divide by the 62.5 to get the Y by itself. So I'm going to end up with $720 per month. Okay. So now that tells me what the total income for the month is. So now I know that this one is $720. So if I know how much the rent, utilities, food, and entertainment is, so that's $450 plus 40, and I know that all total she makes $720 a month, I can subtract to figure out what's left. So what's left is the $720 minus the $450 for rent, food, and utilities, and $40 for entertainment. So when you subtract that, you're going to end up with $230 left over to buy a car and the car expenses like gas and insurance and things. Okay. So the thing I want you to take away from this is a couple of things. One, there are always multiple options when you've got a bunch of holes in your chart. Okay, so usually you can try finding something as long as you have a bridge to get there. Okay. The second is that oftentimes when you've got a lot of percents going on, it can be useful to combine categories, particularly if you have more holes than you need, right? You need one hole that you're going to fill in that value with, right? We can only find one thing at a time. So sometimes it's helpful to combine your categories. Lastly, our tricky problem is the increase and decrease ones. So the key thing here is where is your 100%? And the 100% is always what you're coming from or what the old thing is. So let's take a look at this one. The starting salary increased to $32,400, an increase of 8%. What was the starting salary before the increase? Okay, so again, I'm going to start this out with labels of percent and dollars, because that's what I have in the problem. We have a starting salary. And then there's an increase. And we have a new salary. And if your words are slightly different, that's totally fine. The starting salary is, or the old thing is always going to be your 100%. So I'm going to go ahead and fill that in right away. We're doing an increase of 8%. And so that means if it's an increase, I'm going to add it. If it's a decrease, I'm going to subtract it. So in this case, I'm going to add it and make it 108%. Be careful with the wording. Read it 2 or 3 times to decide where this number goes. So the starting salary increased to $32,400. That means that that is not the starting salary. That's what you increased it to. So that means that that number, the $32,400, goes here as your new salary. What was the starting salary before the increase? So they're asking for this one, okay? So what I'm going to do is I'm going to set up my proportion with percent and dollars. And I'm just going to take the 2 salaries. So I'm just going to ignore the increase part. So starting and new. And I do encourage you to write down all the labels because sometimes having the labels there is what gets our numbers in the right place. So for starting, we have 100 and X. And the new salary row is 108 and 32,400. And then we can go ahead and cross multiply. So we've got these two. And that means that we're going to have 108 times X. It's going to be 32, 4, and 4 zeros. So 324, no. 3,240,000. From here, we're going to go ahead and divide to get our X by itself. So we're dividing by 108. And we end up with X is equal to 30,000. And that should make sense for us because this number, your starting salary, should be lower than the 32,000. So that makes sense. So again, key thing here with increase, decrease is that your old, meaning in this case, your starting salary, is your 100%. Okay. And that's the note that I gave you right here. Whoops. Right. Now let's do this last one as well for a slightly different spin. So one school had a decline in enrollment of 12% and now has 352 students. How many students did the school have before the decline? So we're going to go percent. And the label on my number is students. So that's what I'm going to put here as my label. And then let's see. There was a decline. So a decrease in students. So old enrollment and new enrollment. Old and new is almost always fine in terms of labels for these types of problems. And we know without even looking at the problem that our old is going to be our 100%. Okay. Then we go back to the question and says there was a decline in enrollment of 12%. So the decline in percent is 12. And decline means decrease. So I'm going to take the 100 and I'm going to subtract the 12 and get 88% for my new enrollment. Now be careful, read it twice, read it 3 times. Where does your 352 students go? Well, it says one student had a decline in enrollment of 12% and now has 352 students. So that is after the decline. So the 352 goes down here for new enrollments. How many students did the school have before the decline? So again, they're asking for this one. Okay. Now, this was the same setup as the last problem. I'm not going to do it the same way. I'll do it a different way for you. So if you like option number 2, I'm going to find out how many students did it decrease by. And that way, I can add that back to my 352 to know how many students they started with. So I can then go ahead and put in my equal sign and fraction bars, and I've got my proportion ready to go. And so then I can go ahead and cross multiply, and that's going to give me 88y is equal to 352 times 12, which is 4,224. And then we're going to divide both sides by the 88 to get the y by itself. And we end up with 48. Okay. Now that was not the original enrollment. That is the decline. So that is this number here. So 48 is here. So if we had an old enrollment and it declined by 48 and we have a newer enrollment of 352, in order to get back to the older enrollment, I'm going to go ahead and add that 48. So if you take 352 and add it to 48, right? So old, so new plus decline equals the olds, which is what I'm looking for. So we're going to take the 352 plus the 48, and that's going to give me 400 students as my old enrollment. Okay. What you don't want to do, because it's not going to give you the correct number, you don't want to say, oh, let me take 12% of the new and add it back on, right? The 12% is always in relation to the old thing, okay? So we want to set it up in that way.